So this is the example for block rotor test. In the open circuit test, we have applied the uh, rated voltage, and on the basis of voltage we have measured the other parameters such as W01, I01, W02, so far and so forth, and WOC. So right now we are going to do the short circuit test. Short circuit test is also known as block rotor test. On short circuit test is there in case of transformer, but here in case of induction motor it is known as block rotor test. What do you mean by block rotor test is, here after switch on the main switch, we are going to hold the rotor in such a way that it will not supposed to rotate during our measurement. So when we are going to take the measurement, this shaft cannot rotate, so it will hold with the bare hand. Now I am going to switch on the supply. So main supply is switch on. Now I am going to shift this auto transformer in such a way that here we have the rated current, and the rated current value is 7.2 ampere, on the basis of which we are going to measure the other parameters. So other parameters are based on the rated current, because it is short circuit block rotor test. So now I am going to give the supply, and we are going to vary the auto transformer in such a way that we have reached to 7.2 ampere. So here it is 7.2 ampere. So now we have 7.2 ampere. The voltage here is 300 scale is there. The voltage here is 90 volts. So here we are going to give the 90 volts. The current is 7.2 ampere. The WSC1 is 120 and WSC2 is 20. We are going to multiply this with the multiplying factor. Now I am going to reduce. So for the particular instant we have hold the shaft, and the person who is going to hold this will experience a jerk. When you cross the 4 ampere, you will experience the jerk up to 7.2 ampere. About the multiplying factor, here we have the 10 ampere is the current rating and the voltage rating is 300 ampere, so the multiplying factor is 4. Now for the sake of calculation, we are going to multiply this with 4 and this will multiply with this 4. We have already exchanged the connection so that we have the rating. Otherwise, it is advised that you have to see whatever ratings are there, whatever connections were present on M is shifted to L, and whatever connections which were already present on M shifted to L, and L connections are shifted to M. So that is how we are supposed to write here or give here negative sign. So this is 120 multiplied by 4 will become 480 watts, and here is minus 80 watt is there. So we are going to give, we have to do the calculation on the basis of these readings, and with the help of calculation we are going to identify these two parameters which are the block rotor parameters. So on the block, in case of block rotor test, we have to find it out, the VSC, ISC, WSC 1, WSC 2, and the parameter which were left was WSC is equal to WSC 1 minus WSC 2. So it is this minus, here it is 480 minus of this one 80. So this will become 480 plus 80. So it is 560 watts. So with the help of these connections, these calculations and the formulae, we are going to find it out the two values, that is stator resistance plus rotor resistance and the stator reactance plus rotor reactance. So these parameters we are going to find out by using these rating. So here we are going to find out the parameters, that is equivalent circuit of an induction motor. So this one is imaginary part, just same as that of the part which are present in the transformer. Here this is inductance and the resistance. Thank you.